Hello, Wen. In the last video, we introduced the initialization and arbitration. Now let's get familiar with the refresh state. We named this module SDRAM Refresh.v. I first explained the relationship among these files. In conjunction with the previous knowledge, SDRAM mean control.v in the arbitration module calls SDRAM initialization.v in the initialization module, and SDRAM ref.v in the refresh module. SDRAM mean control.v use top SDRAM.v. To provide SDRAM mean control.v use top SDRAM.v to provide ports for SDRAM module plus.v. Finally, testbed top SDRAM.v calls top SDRAM.v and SDRAM module plus.v to simulate. Let's see how to achieve that in conjunction with the oscillogram. In the SDRAM mean control.v, instantiate initialization and refresh module. In the SDRAM refresh.v, let's first check the assignment under the reset state. Initialization and is under the control of the initialization module. Refresh module just needs to wait for its notification. Refresh counter is set to 0. Refresh request is set to 0. Refresh enable is set to 0 and controlled by SDRAM mean control.v. Refresh command is set to NOP. Refresh delay flag is set to 0. Refresh delay counter is set to 0. Refresh end is set to 0. As the completion of the initialization process, initialization end is set to 1. Refresh counter starts to count. The period that the SDRAM datasheet required is 4096 times per 64 milliseconds, namely 1 time per 15.625 microseconds. We are using a clock with 50 MHz in this example, namely the clock period is 20 nanoseconds. Thus, 15.625 microseconds divided by 20 nanoseconds equals 681.25 clock periods. That means a refresh operation must be done before it. To meet the minimum refresh period, it needs to wait for one more clock period before sending the refresh signal. Thus, here refresh count end is set to 780. When refresh counter is counted to 780, it is set to 0 and then restart counting. Refresh is set to 1 simultaneously, and is sent to SDRAM mean control.v of the arbitration module. When the refresh module received the signal from refresh request, the present state, SW, and refresh request. Because the refresh enable type is while, refresh end is set to 1 soon. It doesn't need to wait for the next clock period. In the next clock period, refresh request set 1 takes effect. The reason why it takes effect in the next period is because refresh enable and refresh request set 1 happen at the same time, and the refresh enable uses non-blocking assignment. If you want to know more about the non-blocking assignment, you can see the previous video. Refresh delay flag is set to 1 simultaneously because refresh request set 1 takes effect. State change to refresh at this time. Refresh end also is 1 at this time, so refresh request is set to 0. Because refresh end type is while and refresh request is set to 0, refresh enable is set to 0 as well. Then, in the next clock period, because refresh request and refresh enable set to 0 take effect, refresh command is assigned to null. Because refresh delay flag has taken effect, refresh delay counter starts counting. Here, I explain the function of refresh delay flag. It needs to keep a minimum period after sending the refresh signal. The specific period is 60 nanoseconds in the datasheet. So we need to set a period that is not less than 60 nanoseconds. Here we set the time interval as 10 time periods, namely 200 nanoseconds. Namely, only after the refresh end set 1 takes effect, other modules can launch. After running 9 clock periods, refresh flag is set to 0. Refresh end is set to 1 and transmitted to the SDRAM mean control.v of the arbitration module. Then the state is set to SW. Let's continue having a look at the next period. Refresh delay flag has been set to 0 at the moment. It cannot satisfy the condition of equaling 1. Thus, refresh delay counter is set to 0 as well. Finally, the refresh operation is done. At the end of this video, in the initialization part, we mentioned that after the initialization is done, initialization command will continuously send null. When the refresh module sends the refresh signal needs to take precedence over the NOP signal to send the SDRAM module plus .v. We can use the if statement to judge the priority of signals. Commands have 18 bits in all. NOP signal and refresh signal in the first 4 bits. Then the result is exactly the refresh signal. NOP signal or refresh signal in the last 14 bits. The result is still the refresh signal. NOP and refresh signals don't specify in the last 14 bits. So this part is not clear about the last 14 bits. When the next part related to writing and reading is done, it will be clear to clarify that the result is exactly read or write operations. Next, assign this value to the command variables. Finally, transition it to SDRAM module plus .v.